Hello and welcome to the SQL Starting Point course. The course objectives. This course is designed to give each student a basic sound understanding of the following topics. Oracle SQL. You will learn how to use the industry standard tool for working with a relational database. You will also learn many other things, from constructing simple queries to creating your own tables. We're also going to cover Oracle SQL Plus. After the course, you should have a good understanding of SQL Plus, from starting it to creating simple reports on it. We will cover also Oracle SQL Developer. You will go over the SQL Developer components and see how it hangs together. During the course, there will be several exercises to complete. I hope you will join in this course and become an established SQL developer using SQL Plus or SQL Developer. Hello and welcome to section 1. The first course content will start with getting started. We'll cover, it's a quick refresher about the RDB, which Relational Database, what are SQL and SQL Plus and SQL Developer. Hello and welcome to Getting Started Part 1. We'll have a quick refresher. RDBMS, which is a Relational Database construct. 4 basic constructs make up relational database: tables, columns, rows, and fields. In addition to the above mentioned, there is the concept of key values like primary keys and foreign keys. To understand relational databases, you need to understand the 4 basic constructs of an RDB and the concept of key values. So a table can be thought of as a storage area, like a filing cabinet, for example. You can use tables to store information about anything, say employees, departments, and so on. A database may only contain 1 table, or it may contain thousands of tables. Rows. If a table has been defined to hold information about, for example, employees, a row is a horizontal cross-section into the table which contains the information about a single employee. A column is the vertical cross-section of a table, or in other words, a column defines each of the attributes about the data stored on a particular table. For example, if you have a table which holds employee information, you could have several columns which determine employee number, name, job, and so on. A field is where rows and columns intersect. A field points to, say, a particular column on a particular row within a table. A primary key is a column that defines the uniqueness of a row. For example, with employee number, you would only ever want 1 employee with a number of, say, 10001 or 221001. Foreign keys. A foreign key defines how different tables relate to each other. For example, if you have defined two tables, one for employees and one for departments, there will be a foreign key column on the employee table which relates to the department code column on the department table. If we take the emp table, we can see that uniqueness of the primary key. So that primary key column is unique. This is a single row representing a single employee. Here. A field found at the intersection of a row and a column. Normal column, not a key. So you can see different values, or maybe you see some values are the same. A foreign key column, which is links employee to department. And here we show graphical illustration of relational operators: restriction, projection, product, join, union, intersect, and difference. Relational operators are used to extract and combine data for selection. They can be thought of as functions that can be performed on data held within a relational database. Restriction is an operation that selects rows from a relation that meets certain conditions. There can be none, one, or many conditions. This is sometimes referred to as a horizontal subset. Projection is an operation that only selects specified columns from a relation and is suitably referred to as the vertical subset. The product operation is the result of selecting rows from two or three relations. The resulting set of rows returned is often very large. Join, this operation is the result of selecting rows from two or two more relations using one or more specified conditions. Joins are often made via foreign key columns. Union, this retrieves unique rows that appear in either or both of two relations. Union all can be used to retrieve all rows from either or both tables. Intersect, this retrieves all rows that appear in both of two relations. Difference, this retrieves rows that appear in one relation only. This is the end of part 1, and I will see you in part 2. Welcome to part 2. RDB properties. A relational database has the following properties. It appears as a collection of individual tables to the user, even though the database may be contained in a single file. The user does not specify the access route and does not need to know how the data is physically stored. The user must know which tables can be accessed by a table name. The user queries and modifies the database using an English-like non-procedural 4GL, otherwise known as Structured Query Language, or SQL for short. The database provides the user with a set of operators for partitioning and combining relations via SQL. Its structure can be modified easily. Table properties. A table on a database has the following properties. Each row on a table should be unique. Each row can be identified by a primary key column. There must be no duplicate column names. Row order is insignificant. Default order is the order in which rows are inserted into a database. Column order is insignificant when the data is stored. Its order is identified when data is retrieved. All fields values or all field values are atomic, or in other words, they cannot be broken down into smaller components. You might come across table definitions in Oracle that have no primary key column, enforcing uniqueness. This is allowed, but under the hood, Oracle maintains uniqueness using a special column called row ID. What are SQL, SQL Plus, and SQL Developer? Okay, what exactly are SQL, SQL Plus, and SQL Developer? SQL is the standard language used for querying relational databases. It allows you to view and change data held within an RDB, as well as allowing you to actually modify the structure of the database. SQL Plus is Oracle's front-end interface to SQL. From SQL Plus, you can create SQL scripts. SQL Plus also has its own set of commands which aid SQL script development, and it also allows you to produce simple reports. SQL Developer is a free integrated development environment that simplifies the development and management of Oracle database in both traditional and cloud deployments. SQL Developer offers complete end-to-end development of your SQL and PLSQL applications, a worksheet for running queries and scripts, a DBA console for managing the database, a reports interface, a complete data modeling solution, and a migration platform for moving your third-party databases to Oracle. So what is next? We have had a quick refresher on the concept of relational database, and we have had a very brief description what SQL and SQL Plus and SQL Developer are. The next section jumps straight in and actually starts on basic SQL commands. I hope to see you in the next section. Welcome to Section 2, Introduction to SQL, SQL Plus, and SQL Developer. The second part, Introduction to SQL and SQL Plus. We'll do Introduction to SQL. some DML and DDL, which data manipulation language or data definition language. And then we'll see how we can start SQL Plus. We also will come across our first lab exercise. So there will be plenty exercise at the end of each session. We'll cover entering SQL commands, basic query block, selecting specific columns, arithmetic operations, column aliases, concatenation, literals, null values, duplicate rows, ordering data. We're also going to cover row restriction using logical operators, using SQL operators, using like, negating a conversion, multi-conditions and operator precedence, basic SQL Plus summary, and then we'll go to lab 2. Section 2. In this section we cover introduction to SQL. Very briefly, before we get into actually using SQL, we'll summarize what can be done with SQL. First, query the database. SQL allows you to easily query data held on the database. Queries can be very simple and only take up a couple of lines, or they can be quite complex and take up several pages of text. Change data held within the database. Changing data is just as easy as querying the data. Existing data can be modified, and you can remove data or insert new data. Change the structure of the database. SQL allows you to actually modify the structure of the database, meaning you can easily create new database objects such as tables, indexes, views, sequences, and so on. DML or DDL. Most SQL commands fall into one of three categories. Queries, you will use these the most. They are for retrieving data from the database, and they are neither DML nor DDL. Commands that allow you to modify the data held within the database, these commands are referred to as data manipulation language commands, or DML for short. Commands which allow you to modify the structure of the database. These commands are known as data definition language commands, or DDL for short. During this course, we will learn how to use commands from all categories. Starting SQL Plus. Before you can use any SQL commands, you must log in into the database using SQL Plus. SQL Plus can usually be found as an icon on your desktop if you are running Windows, or it is available whilst you are logging into a Unix box. If you want to run SQL Plus from the Windows desktop, simply double click on the icon. You will then be asked for a username and password. If you are wanting to start SQL Plus while logged into a Unix box, then simply type SQL Plus from the command line. You will again be asked for a username and password. This is the end of part 1, and I will see you in part 2. Welcome to Introduction to SQL part 2. We can start SQL Plus using command prompt. As you can see here, we can run it by using SQL Plus username and password. So if we hit the enter key, you can see that we logged into the database, Oracle version 12, and you can quit by just typing quit. So we are currently logged out of the database. Our first lab, logging into the database using SQL Plus from the Windows desktop. Once you see the SQL Plus prompt, quit out of SQL Plus. If using Unix or Linux, log into the database using SQL Plus from your Unix session. Once you see the SQL Plus prompt, quit out of SQL Plus. Entering SQL commands. Once you are logged into the database using SQL Plus, you can enter either SQL Plus commands or SQL commands. There are a few things you should note before starting or start typing. Commands may be on a single line or many lines. You should place different clauses on separate lines for the sake of readability. Also, make use of tabs and indents. SQL command word cannot be split or abbreviated. SQL commands are not case sensitive. All commands entered at the SQL Plus prompt are saved into a command buffer. You can execute SQL commands in a number of ways. Place a semicolon at the end of the last clause, or place a / at the SQL prompt. Issue the SQL Plus run command. Basic query block. You know now how to log into the database. We have also covered how to enter basic commands. Let's now try to write our first SQL statement to query the database. The basic query block is made up of two clauses. Select which columns from which tables. We can log into the database first by typing SQL Plus with user and password. And we can run a basic command, select, as we said. And use semicolon to end the script. And we can see that we display the employee name. The statement will select ename column from emp table. You can use star to specify all columns. As you can see, we can select all the rows in their columns. To view the columns, we can use the disk command. So if we type disk imp will tell us the columns and the data types. Selecting specific columns. You can select any columns in any order that appears on the table specified in the from clause. Use a comma as a column separator. Specify columns in the order you wish to see them in. Data is justified by default as follows. Dates and characters to the left, numbers to the right. For example, if we select temp number, temp name, sal from temp, will produce the following result. So we have employee number, employee name, and the salary. Arithmetic operators. At some point you may want to perform some arithmetic calculations based on the data returned by the select statement. This can be achieved using SQL arithmetic operators. Multiply, which is asterisk, divide, / add, which is the plus sign, and subtract is the minus sign. For example, to find the annual salary of all employees, we can use select imp, comma, sal times 12 from M. And you can see the difference between the previous select statement and the second select. Here we multiply the salary by 12 and you can see the result. Column aliases. The heading SQL Plus will give to columns is by default based on the column name. But what about situations as in the previous example? Select imp number sal times 12 from employee. This SQL statement will give you as the following output. Note the second column, sal times 12, not very user friendly. Using column aliases, you can change the heading. Then simply follow the column name with the space and column alias. Column aliases must not contain any white space, and the case is ignored. You can get around this by enclosing the aliases in double quotes. As we can see here, select imp, employee number, comma, salary times 12, annual salary from imp. And you can see now it's much clearer. We have employee number and salary, annual salary, much better. Concatenation. You can merge the output of two or more columns together using concatenation operator. For example, we use select name concatenation operator ename, with alias name from imp. As you can see, we have name equals Smith, and so on, using concatenation operator. A literal is a character or expression in the select clause. For example, select ename works in department is a literal. So if we select, we run this SQL, you can see Smith works in department 20. This is the this expression. Date and character literals must be enclosed in a single quote. Null values. If a row contains a column which has no data in it, then its value is said to be null. Null is a value that's unavailable, unassigned, unknown, or inapplicable. Null is not the same as zero. If null is part of an expression, then the result will always be null. In our example imp table, we have the column com, which is only populated for salesmen. So if we run this query, as you can see, Smith is not a salesman and there is no value here. So the value is null basically. So the value basically salary times 12 will be null whenever the value of com is null. This is the end of part 2, and I will see you in part 3. Welcome to part 3. The NVL function, you can solve the problem of null values causing expressions to be null by using the NVL function. NVL simply puts a value where a null would otherwise appear. NVL can be used with date, character, and number data types. NVL takes two parameters: the column you are checking for null, and the value you wish NVL to return if the first parameter is null. So making use of NVL in the example on the previous page, we have the com as, so if the com is null, the value will be replaced by 0. So whatever the value we have here, salary times 12 plus null, will always be value sal. So if we run this statement, as you can see now, we don't have null values, although we do not have commission, but the value is replaced with the salary times 12, so the annual salary. So the use of NVL in this example always ensures the value of column is assumed to be 0 if it is null, thus ensures the remuneration column is always calculated correctly. Duplicate rows. Whenever you execute a select statement, by default all rows are selected. For example, if we run this statement, it will select all department numbers from M. You can see that we have many duplicate values. 3 departments, 20, 30, and 10. So you can prevent duplicate rows from being selected by using the distinct keyword. Simply follow the select keyword with distinct. For example, here we're using distinct, so we'll see how the statement will display. You can see here we only selected the distinct values, no duplicate values anymore. So the distinct keyword affects all columns in the select clause. Ordering data. The order of rows retained by a select statement is by default undefined. You can use the order by clause to sort the rows. For example, in this statement, we're ordering the employee number. So the result will give something like this. You can see that the order is ascending, in ascending order, from the lowest number to the highest number. So the order by clause is simply added to the end of your select statement. By default, order is ascending. Use descend or DESC after the column name to change the order. There's no limit on the number of sort columns. There's no need to select sort column. You can sort using expressions and aliases. Null values are sorted high. We'll have another example of the order by. For example, in here, we select department number, hire date, ename from order by department number, hire date, descending, and then ename. So you can see that this is the highest. The hire date is the highest, but the department number is ascending. Row restrictions. A simple select statement such as select imp number from imp order by imp number will return all rows from the imp table. But if you only want a list of employees who work in department number 10, you would use the where clause. The where clause must appear after the from clause. You specify conditions in the where clause that must be met if the row is to be returned. Conditions are basically combinations of columns using logical operators and SQL operators. In this example, we're selecting imp number from imp where department number equal 10 order by imp number. You can see that we only selected 3 rows, as in here we only have 3 rows that have department number 10. And they ordered by imp number. So you can see also here it's in ascending order. So that's the lowest and this is the highest. Row restriction using logical operators. The following logical operators are available. the equal to, greater than or equal to, less than or equal to. A where clause is generally made up of three elements: column name, combustion operator or logical operator, and column name. For example, select ename emp number from emp where job equal clerk. So we have four names with the job clerk. Row restriction using SQL operators. The following SQL operators are available between two values inclusive. In matches any in a list of values. Is null is a null value. Like matches a character pattern. In this example, we're selecting emp number from emp table, where department number between 20 and 50. So we're only selecting department numbers between 20 and 50. So by running this statement, you can see the values we have selected. The second example, we are selecting ename job from emp, where department number in 10 in this list 10, 20, 30, 40 and 50. So another example. The next example, we're selecting emp number from emp where our commission is null, and we only selected the employees who are not a salesman. They do not have commission. The like operator is covered on the next page. Row restriction using like. Sometimes you may not know the exact value to search for. For example, you may want a list of all employees whose names begin with the letter S. You perform this kind of comparison using the like operator. The like operator expects a wildcard search button. A wildcard is basically a way to specify parts of a string which you do not know. For example, the modulo sign or the percentage sign represents any sequence of 0 or more characters. The underscore any single character. For example, to list all employees whose names began with the letter S, we write select star from emp where name like S. As S to start, we could put S at the end to extract employee where S is the end. So we want it to start, so we want all the employees, the first letter is S. And we can see the first employee is Smith, the second one is Scott. Negating a comparison. Rather than writing a where clause which says select rows which meet a certain condition, it may well be easier to say select rows which do not meet a certain condition. You do this with a negate expression. We have here a table of negating logical operators. The first one is not equal to. The second one is same as not equal to. The third one, not a column, same as not equal to. The fourth one, not a column, is not greater than. We also have negating SQL operators. Not between two values, not in a list of values, not in a character pattern, is not null, is not a null value. To select all rows where the department is not 10, 20 or 30, we run the following script, which produce no rows. As we can see, all departments we have is 10, 20 and 30 only. To select all rows where the name does not begin with S, we use select star from emp where name not like S modulo sign or percentage sign. In here, after running the statement, we see that there's no names starting with S. Another example, to select rows where the com or the commission column is not null, we use select star from emp where com is not null. And we can see that the values of the com are already here. So we have values. This is the end of part 3, and I'll see you in part 4. Welcome to part 4. Multiple conditions. A where clause is not restricted to a single condition. It can contain any number of conditions. Multiple conditions used together are referred to as a compound logical expression. You can use the and or keywords to create where clause with multiple conditions. A condition using the and keyword is true if both conditions are true. A condition using the or keyword is true if either condition is true. I'm going to use SQL Developer instead of SQL Plus in this session. So if you would like to know more about SQL Developer, please refer to section 6. To select all rows where the department number is 10 and the salary is greater than 1,000, we can run the following script. You can see that we have department 10 and the salary is greater than 1,000. To select all rows where the department number is 10 or the salary is greater than 1,000, we run the next statement. You can see here we have more rows selected because we have option using the or keyword. So we have all rows with department 10 plus all rows with the salary greater than 1,000. To select all employees who were hired before July 1999, whose commission is more than 1,000 but less than 1,500. So we can run the following script. So we only have one record with the commission less than 1,500, and the date is 1981, which is less than 1999. To select all employees who are not clerks but do work in departments 10, 40, or 30, we run the following script. So we can see that we have two rows, both in department 10, and they're not clerks. You can see one of them is the manager, the other one is the president. To select employees who work in department 10 who earn more than 10,000 per annum, or employees who work in department 30 who earn more than 15,000 per annum. We run the following script. And we can see we have mixed departments, 30 and 10, and salaries ranges from 10,000 for department 10 and more than or 15,000 or more for department 30. Operator precedence. When constructing where clause, you need to be aware of operator precedence. This determines how a condition is evaluated, and it can greatly affect the result. Operators are evaluated in a strict order as follows: all logical and SQL operators, not, and, or. Default operator precedence can be overruled by using parentheses. To select all managers in any department and all clerks in department 10, we run the following script. So we see we have three managers in different departments and one clerk in department 10. The second statement says select all rows where department is 10 and job is either clerk or manager. This would only give rows where department is 10 and job is manager or clerk. So we only have two rows where there's one manager and there's one clerk in department 10. If you are unsure as to exactly how a condition will be evaluated, feel free to use parentheses. This is the end of part 4, and I will see you in part 5. Welcome to part 5. Basic SQL Plus. As we saw earlier, the SQL language is actually accessed from within a tool called SQL Plus. Before we finish this section of the course with the exercises, we need to take a look at some of the basic SQL Plus commands you will need to use when working with SQL. We'll quickly cover the following: editing and executing SQL in the buffer, saving, loading, and executing SQL Plus files. SQL Plus buffer. When you enter SQL command at the SQL Plus prompt, it's stored in the SQL buffer, and it will remain there until you enter a new command. If you press return before completing a line, SQL Plus will prompt you for a line number where you can continue to enter the command. You can terminate the buffer by pressing return again. A semicolon, / or entering run will terminate and execute the SQL statement. For example, we can select star from emp using semicolon. Or we can select star from emp and using / which will give us the same result as the previous one. The third one we could use is select star from emp, press return and type run. Which will give us the same result as the two previous statements. So all of the above examples do the same thing. Editing SQL. Once you have entered some SQL, you may want to execute the same code but with a few changes. You could simply retype the code with the changes, or you could use some basic SQL Plus commands to edit what's stored in the SQL buffer. So looking at this table, the first command is append text. Adds text to the end of command line. Change C / old new changes old top new on current line. So change text deletes text from current line. Clear buffer or CL buff deletes all lines from the buffer. Del deletes current line. Input inserts an indefinite number of lines. Input I text inserts a line consisting of text. List or L lists all lines in the buffer. List N lists one line specified by N, as N is a number. List MN lists from line M to line N. ED invokes editor with contents of SQL buffer. Run or R displays and runs what's in the buffer / runs what's in the buffer. Editing SQL examples. Assume you have the following statement in the SQL buffer. If you want to change the job to hire date, you can use the following. And we can run the statement again, and you can see we changed the job to hire date. You can always list what you have in the buffer. Saving, loading, and executing SQL, as well as using the SQL buffer to store SQL commands. You can also store your SQL in files. These files can be edited with your own editor. You can then recall and run these files as you had just typed the SQL commands directly into the SQL buffer. Use the following commands from the SQL prompt. Save file saves the current content of the SQL buffer to a file. Get file loads the content of file into the SQL buffer. Start file runs a file, can also use at file. ed file invokes an editor to edit the file. Exit quits SQL Plus. For example, if we create this small SQL, we can save it to a file, say save demo. So let's create a file demo.sql. We could run it by using the at demo, and you can see the saved file is run again, and we can see the file is created. So we have seen this is the demo.sql. The summary of section 2. So what we covered the select statement with its distinct option star for selecting all the columns or specific columns, and column aliases from table, which we use im table, where conditions and or order by column expression, ascending and descending. Using tabs for clarity, always place different clauses on different lines. As we can see, capital letters makes difference between the select clause and the rest of the statement. We have covered the following: the basic select statement, the distinct keyword, column aliases, the order by clause, the where clause, single and multiple conditions, logical, SQL operators, negating conditions, multiple conditions, operator precedence, basic SQL Plus commands. What's next? Having covered the most commonly used type of SQL statements, the select statement, and also briefly looked at SQL Plus commands, we are now ready to take a look at some of the more complex features of SQL. This is the end of part 5 and end to the introduction to SQL, section 2. Next is the lab. Welcome to lab number 2. So we need to do some lab work, and this is what you need to do. First option, select all rows from the salary grade table. It's part of the Scott schema. Second option, select all rows from the emp table. Third option, select employees who have a salary between 1,600 and 3,000. The fourth option, list department number and department name in name order from the department table. Display all the different job types in reverse order. List the names and hire date of all clerks in Department 20. Option 7. List all employees whose name begins with the S. Option 8. Display the name, job, manager, and salary for all employees who have a manager. Sort the list by salary descending. Option 9. List the name and total remuneration of all employees. The last option, display the name, salary, annual salary, and commission of all salespeople whose monthly salary is less than their commission. The output should be stored by salary highest first. This is the end of lab 2 and end of section 2. Welcome to section 3, row and group functions. Section 3, row and group functions. In this section we'll cover row functions, character functions to start with, lower, upper, and init cap, lpad and rpad, substring, instring, ltrim, rtrim, length, translate, replace. We're also going to cover number functions, round, trunk, sign, cell, and floor. We're also going to cover maths function, Oracle dates and date functions. We have month, underscore between, add month, next underscore day, last underscore day, round, and trunk. We're also going to cover conversion functions, to character, to number, and to underscore date. Also, there's functions that accept any kind of data, which is NVL or not null value, greatest and least, and decode. Also, nesting functions, group functions, group data, omitting groups, and then we'll have a little bit of summary. We see what we actually covered, and then we'll do some lab exercises, lab 3. Hello and welcome to section 3, row and group functions. In section 3, we're going to cover row and group functions. So far, we have seen how to use the most commonly used command in SQL, the select statement. Now that we have this basic knowledge, we can begin to cover more complex features of SQL. In this section, we will cover the following: row functions, grouping functions, and grouping data. Group functions and grouping data. Row functions are basically a predefined or custom-built commands which can be used to modify the data in SQL statement. Row functions have the following properties. They require arguments. These can be constant, variable, column names, or expressions. Functions return a single value. Functions act on each row returned by the query. They can be used in select, where, and order by clause. They can be nested. There are many different kinds of row functions available. They are character functions, number functions, Oracle date arithmetic and date functions, conversion functions and format masks, functions that accept any kind of data type, nesting functions. We will take a brief look at some of the more commonly used functions. We'll look at the following character functions: lower, upper, init, cap, lpad and rpad, substring, nstring, ltrim and rtrim, length, translate and replace. The lower function converts all characters to lowercase. If we run the select name, ename from emp, we'll see that it displays all the names in capital letter. But if we change select lower name from emp, you can see the same names, but they are now lower letter. So lower ename converts the capital letter into small letters. The upper function converts all characters to uppercase. It's opposite of the lower function. The init cap forces the first letter of each word to be in uppercase. Here we take the ename, init cap ename from M. You can see that only the first letter is capital letter. lbad and rbad. Bad's string to the left or right with a specified character until a specified length is reached. In our example, we take in the ename, lpadding it, making the length of it 10, and depends on the length of the ename, we're adding to the left of it dash. Let's run this script to see exactly what I mean. You can see that we're adding to the left. Smith is only 5 characters, so we're adding 5 characters to the left of it. And you see Martin is 6 characters. We only left adding 4 dashes to the left. And right is exactly the same, but to the other side. So rbad adds dashes to the right hand side. If the string is longer than length, then the string is truncated to ln characters, the length character. The substring function is used to extract a portion of a string. So substring will have 3 parameters: starting string, position, and length. So if we run, for example, the following script, select substring ename from position 2, we subtracting only 3 from M. So if we take, for example, Smith from position 2, we extracting 3 letters. So we only extracting MIT, M-I-T, and leaving the H. So we only extracting 3 letters from position 2. In string returns the starting position of string within another string. In our example, this is New York is the string. What we're searching for, the word York, and the position we want to start is position 1. So it will give us the numerical position of York. So if we run this, 5. So it will tell us that York starting in position 1, 2, 3, 4, 5. We haven't mentioned the table dual before. The dual table is a special 1-row, 1-column table present by default in Oracle and other database installations. In Oracle, the table has a single variable character 1 length and column called dummy that has a value of X. It's suitable for use in selecting a pseudo column such as sysdate or user. So if we select system date from dual, the result will be 30 May 18. Ltrim and rtrim. The ltrim and rtrim functions remove portions of string from the left or right. In our example, we have ltrim Oracle O from dual. So we left trimming, we're removing all the occurrences of O from left. So if we run this, the O is removed from the word Oracle. The right will be the same. So if we do L right trim Oracle, if we put E from dual, we'll lose the letter E. So Oracle, this is the string you wish to modify, and O, the string to be removed, all occurrences are removed. So you can put the string which you want to be removed from the string here. The length function returns the number of characters in a string. So in our example, so if we want to know the length of the word Oracle from dual, the answer will be 6. The translate function searches through a string for a character and replace it with another. In our example, we're using the translate to replace the letter F with the letter E. So when we run this statement, you can see the correction here. So it basically remove the F and replace it with E. So this is the string you wish to modify. Searches for this character, replaces with this character. The replace function searches through a string for another string and replaces all occurrences of it with another string. So in our example, we will select replace or a thread, searching, this is the string, we search in this string for the word thread and replacing it with the CLE from Dual. So the word will be Oracle. So again, the string you wish to modify searches for this string, replace with this string. This is the end of part 1, and I will see you in part 2. Welcome to row and group functions part 2. Number functions. We will look at the following number functions: round, trunk, sign, cell, and floor, and mathematical functions. Round. The round function rounds a number to a specified number of decimal places. So in our example, the number you want to round is 10.25. 1, the number of decimal places we want to round it to. So if you run this script, if the number here is negative, then the number to the left of a decimal point is rounded. So in our case, we rounded 10.5 to 10. The trunk function truncates a number to a specified number of decimal places. (10.25), the number you want to truncate. 1, the number of decimal places. So if we run this, we'll have 10.2. Sign. The sign function returns -1 if a number is negative, 0 if a number is 0, and +1 if a number is positive. In our example here, you can see, select sign 10 from Dual, it's given us 1 as a positive. Select sign 0 from Dual, giving us 0. Select sign -20 from Dual, it's negative, so it's giving us -1. Ceil and floor. Ceil and floor functions return the largest or smallest integers which are greater or smaller than a specified number. So in our example, if we want the ceil of 10.25, it will take the ceiling to 11, and if we select floor of 10.25 from Dual, it will take it to only 10. There are more functions available. Here's a list of them. So function power arguments mn raises m to the power of n. Mode mn returns remainder of m divided by n. ABS m returns absolute value of m. Square m square root on m. Log mn logarithm base m of n, sin n, sine of n, sin hn, hyperbolic sine of n, tan n, tangent of n, tan h, hyperbolic tangent on n, cos n, cosine of n, cos h, hyperbolic cosine of n, x n, e raised to the nth power, where e equal 2.7182883, ln n, natural logarithm on n, where n is greater than 0. Oracle dates. Dates in Oracle are stored as a number which represents the following: century, year, month, day, hours, minutes, seconds. The default display format is DD-MON for month and -RR, or DD-MON-YY, which represents a 2-digit day followed by a 3-character month and ending in a 2-digit year. For example, July, 10th July 1999. Let's look at this example. When we select sysdate from Dual, we get DD month, which is MON in 3 characters, and then the year. There is a special Persuado column available in Oracle called sysdate. This returns current date and time, for example, as we see here. Date arithmetic. Arithmetic operators can be performed on dates. The following table describes how this works. Date plus number, result date, adds number of days to date. Date minus number, result is date, subtracts number of days from date. Date minus date, number of days, result, subtracts from another, or one date from another. Date plus number by 24, the result is date, adds number of hours to date. Example of date arithmetic. If we select sysdate minus 10 from Dual, you can see the date will go back to 20 May 18. Current date is the 30th of May 18. Date functions. We look at the following date functions: months between, add month, next day, last day, round, trunc. We already came across these two functions before. Months between. This function returns the number of months between two dates. The non-integer part of the result represents a portion of a month. So in our example here, if we select months between sysdate, which today's date, and sysdate plus 120, which is around 4 months from June, the result will be 3.900 and so on, almost 4. Add months. This function adds a specified number of months to a date. In our example, select add months, sysdate plus 2. So we're adding 2 months to the current date. So the date will be 30th July 18. Next day. The next day function is used to find the next date of the specified day after a specified date. So in our example, what's the date of the next Monday from system date? So if you run this statement, so the next date will be Monday the 4th of June 18. So this is starting date, the string representing the day you are looking for, say i.e. Monday, Tuesday, can also be given as a number where 1 is Sunday and 7 is Saturday. Last day, the last day function is used to find the last day of the month, which contains a specified date. In our example here, select last day using system day, sysdate from dual, and I will give us 31st of May. It's the last day of the month. Round. The round function is used to round dates to the nearest month or year. In our example, we are rounding sysdate to the nearest year, which is 1st of January 18. So date to be rounded can either be month or year. If omitted, then the time element is set to 12:00:00 AM. This is useful for comparing dates with different times. This our script will return the first day of the current year. Trunc function, very similar to the round function, but trunc effectively always rounds down. This is the end of part 2, and I will see you in part 3. Welcome to part 3 of row and group functions. Conversion functions. When you are selecting columns from a table, specifying literals, or using the result of functions, you are working with the specific data types. There will be times when you need to mix and match data types, and you do this using conversion functions. We'll cover the following conversion functions: to character, to number, to date. The to-character function is used to convert a value into a character with or without a specified format. Common format masks, date format masks. We have format mask, YY, YYY, YY or Y, displays year in 4, 3, 2 or 1 digit. The RR returns a year according to the last 2 digits of the current year, and the 2-digit year passed to the to_character function. MON, months, and MM, 3-digit spelled month, full month spelling or 2-digit month number. Q, quarter of year. DY, day, DDD, DD and D, 3-letter spell day, full spell day, day of year, day of month or day of week. WW or W, week of month or year. Time format mask, we have HH or H12, H24. Hour of day, hours 1 to 12 or hours 1 to 24. MI is minute, SS is second, and we have SSS, second since midnight. Common format masks continue. Format mask 9. Numeric position, number of nines determine width. 0, same as 9 except leading zeros are displayed. Dollar, floating dollar sign. Decimal point position specified. Some of examples of 2-character. The first example, convert a number to a character. The second example, convert a date to a character and display as DD MONYYY. As you can see here. The third example, convert a number to a character and display as a 5-digit character. So if we run the statement, as you can see now, the salary is displayed without decimal points. The fourth example, convert a date to a character and display only the time. So as you can see, we're only displaying the time. The last example, list employee salary as a character with some leading text. As you can see, so we have salary equal 800 or 600 or 1250. Two-number, the two-number function is used to convert a character into a number. As we can see here, converting a string into a number. ToDate, the ToDate function is used to convert a character into a date. As we can see, the date in character, we want it to be in this format. So if we run this script, we'll convert the character date into date. As you can see, it's converted to 30 May 18. So basically what means, we're converting the string. So this is the string to be converted, and format, the format mask you wish to apply to the input string This ensures that the string is in a correct date format. If format is omitted, then the default date format, usually be DD month RR, is used. Functions that accept any kind of data type. We will look at the following functions as well: NVL, greatest and least, and decode. We have already covered NVL, so the NVL function returns a specified value if another is null. So in our example, if commission is null, return 0. So if we run this script, you can see wherever there's no commission, the value is 0. So the commission is the value you wish to check for null, and this is the new value. New value returns this if value is null. Greatest and least, these two functions return either the greatest or least from a list of values. So in our example here, the first will return the greatest value within the list, which is 100, and the second one will return the least value, which is 10. The decode function is very powerful. It works like an if statement, but can be embedded within an SQL statement. In our example, the value is grade. We're looking for number 1, number 2, number 3. If grade is number 1, then the bonus will be 15%. If grade is 2, the bonus will be 10%. If grade is 3, the bonus will be 8%. Otherwise, it's going to be 5%. So that is the value we're looking for, and we're searching for this value within the grade, and this is the result. If the result is this, if we find the value, this is what the result will be. Otherwise, the default value will be 5%. So if we run this, as you can see, number 1, 15%, number 2, 10%, number 3, 8%. 4 and 5 are default. We did not look for them, so the bonus will be 5%. This is the end of part 3, and I will see you in part 4. Welcome to part 4 of row and group functions. Nested functions. There will be times when you need to perform 2 or more functions on a single value. The second function may depend on the result of the first, and so on. You can do this kind of thing by nesting functions. In our example, as a simple example, let us say that you want to list all employees and that you want the manager column to contain some readable text. If it's null, you might at first try this example here. This would produce an error because the data types do not match. MGR is a number, no manager is a character. The solution will be to convert MGR to character first, as we have here, the second example, and this will work and produce the results. So if no manager, it will display no manager. Group functions. Single row functions act upon each row returned from a query. Group functions, on the other hand, act on a set of rows returned from a query. This set can be the whole table or the table split into smaller groups. A table split into small groups would be group by clause. This appears after the where clause in a select statement. Group functions continue. There are many group functions available. For example, we have average, returns average on n, ignoring nulls. Count n or asterisk returns number on non-null rows using column n. If asterisk is used, then all rows are counted. Maximum value of the expression. Minimum value of expression. Div, standard deviation of n, ignoring nulls. Sum of n, ignoring nulls. Variance n, variance of n. N can be prefixed with the keyword distinct. This will make the group function only work on unique values of the column specified by n. In our example, to find total paid in salaries to all employees, we can use the sum salary from imp, and this will give us the total salary of all employees we have in the imp table. To find the highest, lowest, and average salary, we can use these three functions here. We have the max for maximum salary, which is 5,000. Minimum for minimum salary, which is 800. Average salary, which is 2,073. And then we have the sum of salary from imp, where department is 20. So we have the total salary for department 20, which will be 10,875. Grouping data. You can split the data in a table into smaller groups. You can then use group functions to return summary information about each group. You split a table using the group by clause. The group by clause instructs the query to return rows split into groups determined by the specified columns. Group by generally takes the following form. This statement will return the average salary for each job for employees who work in Department 20. The data has been grouped by the job, group by job column. The average function here has then returned summary data based on all rows in the table that are in the current group. So if we run the statement, so we have three groups: clerk, average salary 950, managers or manager average salary is 2,975, analyst average salary is 3,000. When grouping data, you should be aware of the following. You are not restricted to a single column. You can group by as many columns as you like, as long as the columns you are grouping by are in the select clause. Rows can be omitted from the grouping data by using the where clause. Groups can be omitted from the result by using the having clause. When grouping data and using group functions, you must ensure all columns in the select clause that do not use group function are included in the group by clause. Otherwise, error will occur. Group data, omitting groups. You can omit groups returned from a query which use group by clause by using the having clause. Having generally takes this form. So this statement will return the average salary for each job for employees who work in Department 20, where the average salary is greater than 1,000. So the having clause can include anything that appears in the select clause. You generally include group functions in the having clause rather than just column names. Because if you had having clause as follows here, this would currently omit all clerks, but this is a very inefficient way to do it. And by the time the having clause evaluated, the rows and clerks have already been retrieved. It would be much better to omit clerks using the where clause. So the previous example here will give us the average salaries. If we run this, it will eliminate anything that's we only want the salaries that are greater than 1,000. So the clerks will not show in our example. So we have all the salaries that's greater, average salaries that are greater than 1,000. Summary of in this section we have covered row functions. Row functions act on each row returned. Character functions, number functions, Oracle dates and date functions, conversion functions and format masks, functions that accept any data type, nesting functions, also group functions and grouping data. Group functions act on a group of rows, many different group functions, group data, omitting groups. What's next? In the next section, we take a look at how to select data from more than one table at a time. We're also going to cover joins, set operators, and subqueries. This is the end of part 4 and the end of row and group functions. I will see you in the next lab exercise. Hello and welcome to row and group functions lab 3 exercises. First, list all employees, give each a 15% pay increase, and display new salary, always rounded down to the nearest whole number. Display name, old salary, and new salary. Option 2. List all employee names in upper and lower case. Also display the name with the first character in upper and the rest lower. Option 3. Create a list that displays the first 2 digits of employee name, followed by the emp number, followed by the rest of the name, display as a single column. Generate the following output. Option 4. Option 5. Display the name, hire date, and number of whole months each employee has been employed. Show the highest first. Option 6. List each employee name along with the salary. If it's more than 1500, if it is 1500, print on target. If it's less than 1500, print below 1500. Write a query that will display the day of the week for the current day. List the maximum, minimum, and average salaries for all employees. List the total salary bill for each job type. Display a count of how many clerks there are. Find all departments that have more than 3 employees. This is the end of lab 3 and I will see you in section 4. Welcome to section 4, querying more than one table. Section 4, querying more than one table. Here we're going to cover joins. So we have product, equi-join, table aliases, non-equi-join, outer join, and self-join. We're also going to cover set operators, union, intersect, minus. Also subqueries. We'll have single row, multi-row, any, some operators, all operators, correlated, and exists operator. We'll have a summary regarding what we covered in this section, and then we'll have lab 4 to cover some topics we already discussed. Welcome to section 4. Section 4, querying more than one table. There will be times when you need to select data from more than one table at a time. This section covers all the basics of doing this, and we will cover joins, set operators, subqueries. So far, any queries we have seen have been from a single table at a time. But SQL allows you to query many tables at the same time through the use of joins. We will now cover some of the basics of joining tables within a select statement. We will look at the following types of join: product, equijoin, non-equijoin, outer join, self-join. The where clause is used to construct a join. Joins product. If you construct a select statement which contains information from two or more tables without specifically linking any of the columns from one table to the next, the resultant query would be what is known as a product, sometimes referred to as a Cartesian join. This basically means that all rows from all tables are returned in every combination. So for example, let us say we have two tables, imp with 14 rows and department with 4 rows, and we enter the following statement. This query will return all rows from both tables in all combinations, resulting in 56 rows, 14 from the employee table and 4 from department. So we have 56 rows. You will rarely need to perform this kind of query, but it's mentioned so that you are aware of the result of a product join. If you unintentionally create one, then the result would be very different to that you might expect. Imagine two tables with over 1 million rows each. Joins equa. An equijoin is a join which directly links columns from one table to another, or in other words, an equijoin joins tables where a column on one table is equal to a column from another table, as in this example here. Let us say you have the following statement: select ename department from imp. This is okay, but if instead of displaying the department number, you want to display the department name, you would have to create an equijoin from the imp table to the department table, as follows here. This statement joins the imp and department table using the department number column, and in English the statement reads: select the ename column from the imp table and get the dname column from the department table. Only select department rows where department number on department is the same as department number on the imp table. So if we run the statement, you can see the result. It's just we're selecting where we have department number in both tables, which is the same. Table aliases. As a rule, when selecting data from more than one table, you should qualify the column names you use with the table name. This removes any ambiguity if there are any duplicate column names across different tables. You do this by prefixing a column name with the table name, followed by a dot. A better method of this is to use table aliases. A table aliases is very similar to a column aliases in that it is a method of renaming a table only for the purpose of the query. You can then use this alias within your query as if the table were exactly called by the alias. This can save a lot of typing, making SQL easier to read and allowing for self-joins. So the syntax for a table join is simple. Just follow the table name with the alias, as we see in our example here. We're using e.name, d.name from ME department D, where D department number equal E department number. Column names can also improve performance of your query because you are telling the system exactly where to find the column. Joins non-equal. A non-equal join is used where a value column is within a range of values rather than equal to a specific value. As an example, the relationship between the imp and salary grade table is an equal join, in that no column on the imp table corresponds directly to a column on the salary grade table. The link between the two tables is that the salary column, or sal, on the imp must be between two values found on salary grade, as we can see here. This statement reads: select the E name and salary column from the imp table and get the grade column from the salary grade table. Only select salary grade rows where the salary column on imp is between the low salary and high salary columns on the salary grade table. As a general rule, when joining tables, you need number of tables minus one join conditions. So the join three tables, you would require at least two conditions. So if you have two tables, you need one join. If you have three tables, you need two joins. So we can run this statement to see what the result will be. As you can see, salaries are between two salary grades. Joins outer join. An outer join allows you to join tables together and still return rows even if one side of a condition is not satisfied. For example, the department table has 4 departments: 10, 20, 30, and 40. And the imp table has employees in all departments except department 40. So if you were to write some SQL to join the two tables together using a standard equal join, the row from the department which does not appear in M would not be in the return rows. As you can see here, all the departments. So we're showing here all the departments with the employees. So there's no departments where there is no employees are showing. But if we run this script here, you can see the plus sign at the end. We'll see more records. If we run this query, we see 15. So The operation department has no employee. The plus in the above statement creates an outer join. It basically says still return a row from department even if the join condition fails. When creating outer joins, you must put the plus sign on the side of the condition where no data will be found. In this case, when SQL has retrieved department 40 from a department table, it will not find any rows on imp for department 40, but the department row is still returned. Join self. By using a self join with the table aliases, you can join a table to itself. A self join basically allows you to select from the same table more than once within the same SQL statement. This is very useful if a table has rows on it which relate to other rows on the same table. For example, the imp table holds employees and each employee has a manager, except the big boss. This manager is stored on the same table, so you would need a self join if you want to create a statement that listed all employee names along with their manager name. And we'll have an example here. In this example, you can see that employees and their managers, few employees, they have the same manager. So the above statement says select employee a name from imp table and call it employee name, then select employee name again and call it manager name from imp where employee number imp num is the same as the manager or MGR stored on the first record. This is the end of part 1 and we'll see you in part 2. Welcome to querying more than one table part 2. Set operators. We have covered the concept of set operators in the introduction to relational databases at the start of this course. So far we have covered the restriction with the where clause, projection with the select clause, joins, product. We will now cover union, intersect, and minus. Union, intersect, and minus set operators are used when you need to construct two or more queries and you want to see the result as if it were a single query. The queries you use could be totally different, i.e. different tables, or they could be using the same table but using different where or group by clause. The union set operator combines the result of two or more queries and returns all distinct rows from all queries. It takes this form as we have here. This statement would first of all select all jobs from imp table where the department is 10, then select all jobs from imp table where the department is 30. The result of both these are combined and only distinct rows are returned. As you can see from the result. Union all, instead of using union, you could use union all, which would return all rows from both queries. The intersect set operator combines the result of two or more queries and return only rows which appear in both queries. It takes this form. So this statement would first of all select all rows from department table, then all rows from imp table, and only where the data is found in both queries would the data be returned. This is effectively saying select all department numbers where employees can be found. As you can see the result. The minus set operator combines the result of two or more queries and returns only rows that appear in the first query and not in the second query. It takes the form of the following. So this statement would first of all select all rows from department table, then all rows from imp table. Data would be returned if it was found in the first query and not in the second query. This effectively saying select all department numbers which have no employees. Set operator rules. There are a number of rules you should follow when using set operators. You must select the same number of columns in each query. All corresponding columns must be of the same data type. Duplicate rows are always eliminated except when using union all. Column names are derived from the first query. Queries are executed from top to bottom. Can use multiple set operators at the same time. Can include an order by at the end of last query. A useful way to specify a column in an order by is by using the column position rather than the name. For example, to sort the output from a set operators by using by the first column, as we have in our example here. Subqueries. A subquery is basically a select statement within another select statement. They allow you to select data based on unknown conditional values. So a subquery could take the following form. So the subquery is the part between the brackets from here to here. This part of the query is executed first, just once, and its result is used in the main outer query, which is this one. Single row subqueries. A single row subquery is the simplest form of subquery. It returns a single row to the outer query. That in turn uses the result to complete itself. For example, to find all employees who earn the lowest salary in the company, we would use a subquery. If we think about what's needed first, we need to determine what the lowest salary is. We need to select all employees who earn this amount. So the finished product or the finished query will be as follows. Select imp salary from M where salary equals select minimum salary from employee table. The above statement executes the subquery first to find the lowest salary and then uses the single row result of that query to find all employees who earn that amount. So let's run the subquery and displays the Smith with the minimum salary. Another example, let us say we want to find all the employees who have the same job as Blake. And this query executes the subquery first to find what job Blake has, and then it uses the single row result of that query to find all employees who have the same job. So let us execute and see what the job Blake is doing. As you can see, Blake's job is manager. Multiple row subqueries. Subquery can return more than one row, but you must use a multi-row comparison operator such as in the outer query or an error will occur. And let's have a look at an example. This query executes the subquery first to find the lowest salary, minimum salary in each department by using a group by to narrow the departments. Then it uses each row returned from that query to find all employees who earn that amount in each department. The AnySum operator compares a value to each row returned from the query. For example, this query executes the subquery first to find all distinct salaries in department 30, and the greater than any part of the outer query says where the salary column in greater than any of the rows returned by the subquery. This effectively says list all employees whose salary is greater than the lowest salary found in department 30. The all operator compares a value to all rows returned from the subquery. In our example, we replace the any by all. So the above statement executes the subquery first to find all distinct salaries in the department 30. The greater than all part of the outer query says where the salary column is greater than all of the rows returned by the subquery. This effectively says list all employees who earn more than everyone in department 30. When constructing subqueries, you should be aware of the following. Order by can appear in the outer query only. You can nest subqueries to a level of 255. Subqueries can be used with the having clause. For example, to list the department which have an average salary bill greater than the average salary bill for department 30, we'll write it in our example as here. This is the end of querying more than one table part 2, and I will see you in part 3. Welcome to querying more than one table part 3. Correlated subqueries. A correlated subquery is a way of executing a subquery once for each row found in the outer query. A correlated subquery works as follows. Get a candidate row from outer query. Execute subquery using candidate row data. Use values from subquery to either include or exclude candidate row. Continue until no more candidate rows are found in the outer query. A correlated subquery is identified by the use of an outer query column within the subquery. They are useful when you need the subquery to return different results based on the outer query. As an example, let us say we want to list all employees who earn a salary greater than the average for their department. A standard subquery would not work because the rows returned from the subquery will not be related or correlated to the rows in the outer query. Using a correlated query, you would have something like this statement. This query says select all employees as candidate row, then find the average salary for the current department using this average. Either include or exclude the candidate row. The key to this is working is the table alias used in the outer query. We would need to ensure the emp table is called something different in both queries. Otherwise, we would not be able to link the columns together. The exists operator. You can use the exists operator with a correlated subquery. This is used to determine if any rows are returned from the subquery. If any are returned, then the condition is true and the row in the outer query is returned. For example, to select all employees who manage someone, will have this query here. This query says select all employees as candidate rows, then find an employee whose manager is the employee in the outer query, and if an employee was found in the subquery, then return the row in the outer query. You can use not exists operator to check if no rows are returned from the subquery. If you use not exists in the example we have here, you will get all employees who do not manage anyone. Summary. In this section we have covered a lot of ground. we have looked at some of the more complex types of queries. We briefly covered ways in which you can select data from more than one table at a time. Joins, product equa, non-equa, outer and self, set operators, union, intersect and minus, subqueries, single row, multi-row, and correlated. What's next? In the next section, we take a quick look at using DML and DDL to modify data within the database and how to change the structure of the database. This is the end of querying more than one table section. Next is Lab 4 exercises. Welcome to querying more than one table Lab 4 exercises. The first options list all employee names along with the name of the department they work in. Option 2, list employee names along with the department name, department number, and the location. Produce a list of employees with their salary and salary grade. Display departments with no employees. List all employees along with their manager's name. The query produced for question 5 will probably not have listed employees who have no manager. So change the query to show these. Display no manager if no manager is found. Find all employees who earn the highest for each job type. List all employees with the A star against the mostly recently hired one. Use the union operator. This is the end of Lab 4 and I will see you in Section 5. Welcome to Section 5. Section 5, Modifying Data and Database. We're going to cover here insert new data, update existing data, deleting data, transaction processing, commit, rollback, and save point, using DDL, tables, indexes, synonyms, and privileges, views, and sequences. And then we'll have summary, discussing what we covered, and then we'll have lab to finish the section. Welcome to Section 5. Section 5, Modifying Data and Database. Modifying data and database. So far, all the SQL we have looked at has been to do with querying data using the select statement. Now we are ready to take a look at other type of SQL commands, DML and DDL. DML is SQL's data manipulation language. It's used to modify data held within the database. DDL, or data definition language, is used to modify the structure of the database. In this section, we cover the following: using DML, inserting new data, updating existing data, deleting data, transaction processing. We will also use DDL, changing structures or creating new tables, indexes, synonyms, privileges, views, and sequences. If you need to create new data within the database, you use the insert statement. This allows you to create new rows on any table as long as you have the correct privileges. This statement says, insert a new row into the department table, set the department number column to 50, dname or department name to marketing, and loc or location to London. Inserting new data. The insert statement can be used in a number of different ways. Specify only required columns. If you want to insert a row but do not want to insert values into certain columns, then simply omit the column name from the insert statement, unless there is a not null constraint on the column. Also, specify no columns at all. If you want to always insert a value into all columns, then you do not need to give the column names. Just ensure values clause matches the table correctly. You can insert rows into a table based on rows from another table. Almost anything that can appear in a select clause of a select statement can also appear in values clause of the insert statement. Inserting new data examples. To insert a row into the department table, only specifying 2 columns. We can see from this example, inserting department number location into the department number. Values 60 and Daventry. Values must match the column names. To insert a row using rows from another table, we can see here, insert into department number, department name, select department number, department name from all table or all department table. We can create all department table as using this query here, create table all department as select star from department. This will create a table based on all table based on this department table. To insert a row using rows from another table and utilizing a row function, you can see here inserting into department number, department name, select department number, init cap, department name. We already come across init cap, which the first letter of the department will be capital letter, from alt department. Updating existing data. If you need to change some data within the database, you use the update statement. This allows you to change a single row or many rows at the same time, as long as you have the correct privileges. So if we look at the our example here, you can see we're updating M table. Set the salary equals salary times 1.1, where the job is equal clerk. So we're only updating where the job is equal clerk. This statement says find all employees whose job is clerk and set their salary to itself multiplied 1.1, or in another word, give all clerks a 10% pay increase. When using the update statement, you should be aware of the following. If the where clause is omitted, then all rows on the table will be updated. The where clause can contain anything that would normally appear in the where clause for the select statement. It's possible to use subqueries and correlated subqueries in the set clause. To give the employee Scott a new job, change of department and a pay rise, We run the following statement. Update imp, set job equal salesman, salary equal salary times 1.25, a 25% pay rise, and change the department to department 40, where the name equal Scott. Deleting data. If you need to delete data within the database, you use the delete statement. This allows you to delete a single or many rows at once, as long as you have the correct privilege. For example, to delete all rows where job is manager, run delete m where job equal manager. So this statement says delete all rows from the emp table where the job column is manager, or in other words, gives all manager the boot. Delete them all. It's also possible to use subqueries with the delete statement. Another way to remove all the data from a table is using the truncate table command. Let's have a look at an example. Truncate table employee. The truncate table command effectively flags the table internally as empty without actually deleting any rows. It's very fast and useful for clearing out tables with many hundreds of thousands or millions of rows. Truncates are DDL, not a DML. Not a DML. A truncate moves the high water mark of the table back to 0. No row level locks are taken. No redo or rollback is generated. All extents except those defined in the minimum extent parameter are deallocated from the table. By resetting the high water mark, the truncate prevents reading of any table's data. So truncate has the same effect as delete, but without the overhead. There is, however, one aspect of a truncate that must be kept in mind. Because a truncate is DDL, it issues a commit before it acts and another commit afterwards, as no rollback of the transaction is possible. So once you run commit, the records are gone. This is the end of modifying data and database part 1, and I will see you in part 2. Welcome to modifying data and database part 2. Transaction processing. Oracle ensures the consistency of data through the use of transactions. Transactions give you more control when changing data and will ensure data consistency in the event of a system failure. A transaction can be thought of as a single consistent change to the database, which may directly relate to some kind of business functionality. This change to the database may consist of a single or multiple DML statements. For example, in a banking system, a transfer funds transaction would involve the transfer of funds out of one account and then further transfer into another account. This would require two DML statements, but is considered a single transaction. Transaction processing allows you to perform all the DML you need before committing the changes to the database. This ensures that both of DML statements are always complete, and in the event of a failure, none of the DML statements would complete. There are two types of transactions. DML holds a number of DML statements. DDL holds a single DDL statement. A transaction begins with a DDL command is issued first, DML statement issued after a commit. Transaction ends when a commit or rollback command is issued. DDL command is issued, you exit SQL Plus, system failure will auto rollback. The commit command. Whenever you issue a DML statement which changes the data held within the database, you are not actually changing the database. You are effectively putting your changes into a buffer. And to ensure this buffer is flushed and all your changes are actually in the database for others to see, you must first commit the transaction. You can do this with the commit statement. This code will update all department rows, then commit the changes to the database. After the commit command has run, the following is true. Your changes are in the database and permanent. The current transaction has ended. Any locks are released. The rollback command. If you have started a transaction by issuing a number of DML statements, but you then decide you want to abort the changes and start again, you need to use the rollback statement. So this code will update all department rows, then roll back the changes. This will effectively be as if you had never issued the update statement. After the rollback command has run, the following is true. All of your changes will be lost. The current transaction has ended. Any locks are released. The save point command. You can split a transaction up into small portions using the save point command. Save point allows you to specify markers within a transaction, and these markers can be easily rolled back if needed. Let's have a look at our example here. So this code will update all department rows, create a save point, and then update all employee rows. Then a rollback is issued only back to the last save point, then _ department. This will effectively discard your changes to the emp table, leaving only the changes to the department table. The final command will commit any changes left to do. In this case, we only committed the changes to the department, and we rolled back the changes to the employee table. Keep in mind the following about transaction processing. Other database users will not see your changes until you commit them. An uncommitted transaction is one which holds locks on the data. For example, if you update a single row without committing, other people will still see the unchanged row, but will not be able to change it themselves until you either issue a commit or rollback. Using DDL. DDL is a subset of SQL commands that allow you to make changes to the structure of the database. We'll briefly cover the following kinds of database objects: tables, indexes, synonyms, privileges, views, and sequences. Using DDL. When working with any kind of object within the database, there are usually three basic commands that apply to all objects. These are create, used to create an object; alter, used to alter, change an object; drop, used to remove an object. Column types and data types. All columns on a table must be given a data type, as this determines what kind of data the column can hold. A few of the more common data types are: number, holds number data of any precision; number W holds number data of W precision; number WS holds number data of W precision and S scale, i.e., for example, 10, 2 is a number up to 10 digits in length, with 2 digits after the decimal point. Varchar2 W holds variable length alphanumeric data up to W width. Char W holds fixed length alphanumeric up to W width. Date holds date and time data. The create table command. To create a new table within the database, you use the create table command. In its most basic form, the create table command has the following form: create table, say department new, department number. Department number is a number data type. Department name is varchar 12 length. Location is varchar 12 as well. So this statement will create a table called department new with 3 columns: a number column called department number, a 12-digit varchar column called dname, and another 12-digit varchar column called location or log. If we run this statement, it will create a table for us. Table department new created. When creating a table, you can ensure that no null values are stored in a column by using the not null constraint. For example, to create the department table and to ensure no null values are ever inserted into the department column, we can create it as the this form. So we're saying department number not null. Describe the SQL command. You can list columns on a table from SQL Plus using the describe command or disc command, as we done early on. Department table, we can run this, and this will describe the table. The drop table command. A table can be removed from the database using the drop table command. The format is drop table name. If we can see our example here, we can create a table. Table is created. We can drop the same table again by using the drop table command. Table department new dropped. Be aware, once a table has been dropped, it cannot be recovered. Also, all data on the table is removed. The alter table command. A table can be altered using the alter table command. This command allows you to do many things. We will look at how you can add an extra column to a table. In our example, we will create first table with 3 columns. Table created, we can describe the table. Table will have 3 columns only. We can alter the table and add the comment column. Table altered. We can describe the table now again. And we can see that the table have 4 columns. This is the end of modifying data and database part 2, and I will see you in part 3. Welcome to modifying data and database part 3. Using DDL indexes. An index is a data structure within the database that allows you to provide quick access to data on a table via a particular column or columns. It can also serve as a method of ensuring no duplicate records can be stored on a table. For example, a common column to use when querying the emp table is emp number. This column should also be unique, since no 2 employees should have the same number. When you query the emp table, for example, using the emp number column, if no index was present on this column, then the database would have to sequentially go through all records on the table until the required one was found. An index would provide a faster method of querying this table. You can create indexes with the create index command. In our example, to create a unique index called emp index 01 on a emp table using the emp number as a column, we use the create unique index emp index 01 on emp. This is the table name, and this is the column we're trying to index. And to create a non-unique index on the emp table using the employee name, we can create index emp index 02, for example, on emp table, the column ename. And to create non-unique index on the emp table using the employee name and hire date columns, we use the create index, for example, index 03 on emp table, emp name and hire date. This is normally called a composite index key. The create synonym command. Within an Oracle database, there is an object called user. This is effectively a space within the database for a particular user. The user of that database user would create tables belonging to his user. If another user wants to access these tables, they would normally have to qualify the table name with the username first. For example, if user HR creates a table called countries and a user Scott wants to list all rows on HR's countries table, he would have to enter select star from HR.countries. A much better method of accessing the table would be to only have to specify the table name. You can do this if a synonym under Scott user exists. In our example, we can see that if Scott tries to see this table which belongs to HR, he will not be able, he hasn't qualified it, so we'll have an error. But if he runs this script using HR schema, HR user's country, he will be able to see the records within the table. So the best way, instead of qualifying the countries using the HR, Scott can create a synonym countries for HR countries. So if Scott creates synonym, now Scott can select records from the countries table without using the HR schema. So now he will be able to see the records exactly. The grant and revoke commands. With the synonyms, if Scott has a table called emp and HR wants to query it, or even insert, update, or delete it, HR must first be given the correct privileges to allow him to do this. Many privileges exist, and the most common ones are select, insert, update, and delete. So to give HR select and insert privilege on Scott's emp table, Scott would like to Scott would have to enter grant select insert on emp to HR. As we can see here, so grant select insert on emp to HR. A privilege can be removed with the revoke command. To remove HR's insert privilege on Scott's emp table, we type revoke insert on emp for HR. The create view command. Let us say you have constructed a very useful and complex query, and another user says, I could do with the same kind of query. You could just give them the code and let them run it themselves, but a better method is to create a database view based on your query. A view is basically a virtual table which is made up of the rows that your query returns. For example, if you have a query that lists employee names along with the department names, you could just create a view like this here. Create a view emp department as select employee name, we call it employee name, and the name as a department name from employee table and department table, where the department number equal department number in the employee table. And the once the view is created, you can select it as you select the table. So this statement will create a view called emp department, which will contain two columns, employee name and department name. And you can now access this view as if it were a table. The drop view command. A view can be removed with the drop view command. For example, in our case, we can drop the view we created here by just running this script here, and the view is dropped. The create sequence command. Assume that you have a new table contains a column called sequence number, and you always want to populate this column with the sequential number. A good way to do it is to create a sequence, then reference the sequence in your insert statement. Sequence is simply an object within the database that returns a number usually. The next in sequence. To create a sequence, use the create sequence command. In its most basic form, it has the following syntax: create sequences and sequence name, increment by say n, start with m. So to create a sequence called sequence 01, which starts at 100 and increases by 10 each time you call it, we'll have it like this: create sequence sequence 01, increment by 10, start with 100. Referencing a sequence. You have created a sequence called sequence 01. You can reference it in two ways. The first being by using the next val pseudo column to get the next number. So in our example, if we run this, so the next number is 100. This would return 100. If you run this SQL again, it would return 110. So let's run it again, bring in 110, because we incremented by 10. You can also retrieve a sequence current value without increasing its value with the current value pseudo column by running this script. So it's just playing the same current value. Drop sequence command. A sequence can be removed with the drop sequence command. For example, to drop the sequence we created, we can run drop sequence name. Say sequence SEQ01 dropped. Summary of this section. In this section we have covered both how to use DML and DDL, and specifically we have seen insert, update and delete data, transaction processing, create, delete and altering tables, indexes, synonyms, privileges, views and sequences. What's next? As far as SQL is concerned, we have pretty much finished. All that's left to do now is to take a quick look at some features of SQL Plus. This is the end of modifying data and database, part 3, and end of section 5. Next is lab 5 exercise. Hello and welcome to modifying data and database lab 5. Option 1, write an SQL statement to give all employees a 25% pay increase. Commit your changes and view the table. Give all employees who work in New York an additional 5% pay rise. Roll back your changes and view the table. Create a new department called IT located in England. Remove the department you created in question 3. Create a sequence called info underscore sequence. Start it at 10 and increment it by 1. Create a new table called employee info using the following table as a guide. Insert a row into the new table. Set info ID to be the next value from the sequence you created. Set imp number to a valid employee number, info date to today's date, and enter some text into info column. Create synonym called e-info for your new table. Select all rows from your new table using the synonym. Remove the new synonym and table. This is the end of modifying data and database section. Welcome to section 6. In section 6, we're going to cover more SQL Plus, SQL Plus variables, ampersand variables, double ampersand variables, basic SQL Plus reporting, adding a page title, setting a breakpoint, saving output to a file, summary, and then we'll have lab 6 to finish the section. We're also going to cover installing Oracle software and test database, and installing SQL Developer and SQL Developer overview to finish this section and finish the course. Hello and welcome to section 6, more SQL Plus. We have already seen a little of SQL Plus. We will now cover a little more on how to use SQL Plus and what it can do. We'll briefly cover SQL Plus variables and also SQL Plus reporting and saving output to a file. So SQL Plus variable is basically a way of storing a value in a temporary space. This value can then be referenced from within a SQL statement. We'll take a very quick look at ampersand substitution variables, double ampersand substitution variables. There are other types of SQL Plus variables available which are not covered on this course. A single ampersand substitution variable is a method of asking the user for input before some SQL executes, then substituting the value entered for the reference variable within your SQL. Simply prefix a variable name with a single ampersand, and SQL Plus will prompt you to enter a value at runtime. For example, if we run the following SQL script, if you run this SQL before anything is done, you will be asked to enter the following. Let's run it and see. Enter value for department number. You now enter a valid value, and SQL Plus will substitute ampersand department number for whatever you enter. Let's enter department 10. The value entered into a single ampersand variable is not remembered. This means if you execute the same SQL again, you will be asked for a valid value. Let's try again. Enter a number. So if we enter now 20, we'll see records or rows from department 20. Double ampersand variables. A double ampersand substitution variable is almost the same as a single ampersand variable. The only difference is that the value is remembered. You only need to enter a value once. And if we enter 30, so it's executed for department 30. Let's run the SQL again, and it's executed with the same department 30. So the value was remembered. Basic SQL Plus reporting. The result of a query are displayed in a very simple and plain manner. SQL Plus allows you to add basic formatting to this output to create simple but effective reports. SQL Plus reporting is a quite complex topic and beyond the scope of this course. Therefore, we will only cover the most basic areas. This should be enough to give you a feel for what can be achieved with SQL Plus. We'll cover adding a title to the page, setting breakpoints. Adding a page title. You can use the SQL Plus ttitle command to add a title to a page, simply entering the title equal my title. Before you enter your SQL, and the report will be headed with the with whatever you set the title to be. You can also add a title to the bottom of the page using btitle. So that's for the top of the page, ttitle, and btitle to the bottom of the page. For example, if we added a title to the M table and select some records, you can see now we have a title employee list. Setting a breakpoint. If you have a query that selects some repeating data, or you want to section out different rows, you can set up a breakpoint to do this. For example, if you have a query which simply selects the department number and employee name columns from M, you may want to select out rows for each department and also only print the department each time it changes. In previous example, we print departments with every row. If we run this SQL with the break, as we said here, we set the title to my title, break on department number, skip 1. Let us see the result. So you can see now department only changes once. So the break command says set up a break point on department number and skip a line each time it changes. So we basically have skipping a line here every time a department changes. Saving output to a file. You can save the output from SQL Plus using the spool command. You simply enter spool and file name before you execute your SQL statement. And file can be any valid file name, and if you omit the file extension, then it will default to .lst. Once you have entered the spool command, all SQL Plus output is saved to the file. To switch off spooling without leaving SQL Plus, you just enter spool off. Me today, that's the file name. And if we run again, and we can spool off. If we go and check the file, host, and you can see the file me today.list is created. So all the script is stored to this file now. Summary. So SQL Plus is a very powerful tool, and it can be much more than described on this course. But you should now have an idea as to what can be achieved using SQL Plus. We briefly covered SQL Plus variables, SQL Plus reporting, saving output to file. What's next? This is the end of the course. We have covered an awful lot of topics in such a short space of time. Don't be concerned if you haven't quite taken it all in, as this course was really designed to give you a taster of SQL, SQL Plus, and SQL Developer. You should be equipped with enough knowledge to make it easy to further progress your knowledge in these areas. I suggest you get to work with the SQL Plus, and SQL Developer as soon as you can. Read any documentation you can on the subject, and you will be fully fledged SQL Plus, and SQL Developer in no time. This course has also given you a good grounding for one of the follow-up courses, PLSQL, packages, procedures, and triggers. This course covers Oracle's procedural extension to SQL in the form of PLSQL, a fully functional programming language. This is the end of more SQL Plus and section 6 and end of the course. Next is lab 6 exercises. Hello and welcome to introducing Oracle's SQL Developer. Session objectives. first objectives of this session is to become aware of Oracle's SQL Developer product and its features, and to be able to create, modify, and test both SQL and PL/SQL using SQL Developer. Using SQL Developer's objects browser to examine and or to alter existing objects and to create new objects. Also to debug stored PL/SQL procedures and functions using SQL Developer, and to customize SQL Developer to your personal preference. Oracle has released the free SQL Developer tool, formerly known as Project Repertoire, and it's super. If you have ever used the free Toad tool or PostgreSQL Developer, this tool will feel familiar. Plus, it has more features and supports Oracle 10G onwards. SQL Developer is a Java-based GUI tool. Works in Windows, Unix, and Linux. Power of SQL Plus without a local Oracle client installation. Intuitive software, not completely new, based upon JDeveloper. Provides features often found only in expensive third-party software, including GUI, browsing of database objects, creation, deletion, and alteration. Debugging complete with breakpoints. Query execution, database reporting, multiple connections, and also tuning features. Where can I get it? Okay, so SQL Developer is freely downloadable from Oracle using the showing this highlighted URL. Current release as of March 2018 is 18.1. Two versions are available for Windows 64-bit with JDK 8 included, which is about 428 megabytes. Also, there is Windows 32-bit or 64-bit, which is 350 megabytes without JDK. Is the install complex? Taking a page from many open source products, SQL Developer installs by simply unzipping the file downloaded from Oracle. No registry entries in Windows, and no desktop starter bar manipulation in Windows. No need for Oracle client or a tnsname.r file. Not an installed Windows program. No need to uninstall or back out anything. Simply delete the installed directory. I find it useful to create a Windows shortcut, but it is not necessary. It's up to you. Major features of SQL Developer. Major features of SQL Developer include SQL worksheet for writing, testing, SQL, PL/SQL, and script files. GUI object navigator allowing creation, deletion, and alteration of Oracle objects. Yours and those you have access to. PL/SQL debugging, including breakpoints and manipulation of variables. Multiple connections, explain, plan. To start it, just execute the SQL Developer.exe program. You'll find it within the unzip directory. Requires Java 1.5 or later for execution. Excellent tutorial and help are part of the install and also available on Oracle's website. First execution asks if you want to migrate settings from earlier install, if you have it. First execution also asks which file types to associate with the SQL Developer. Upon entering the screen above appears, right-click on the connections and choose New Database Connection. Enter connection name you choose. Enter user ID and password. If shop security permits. Enter host name, port, and SID, service name. Get all this information from your DBA. That's if you are working on a test environment or or production environment. I'm sure you'll not be able probably to manipulate objects within the production environment, but I'm sure you will be able to manipulate or create your own test environment. And then choose test to test the connection. It will tell you whether the status is successful or not. After logging in to a connection, SQL Developer shows three sub-panels. Expandable list of the objects associated with the connection, schema, user ID. SQL worksheet, where you write your script, and result area. The SQL worksheet area has a dialog box where SQL may be keyed, viewed, and modified, along with an expandable snippets panel providing code fragments. Note that the pull down showing the connection that will be used to execute any SQL, PL/SQL or scripts in the worksheet. This is the end of part 1, and I will see you in part 2. Welcome to part 2. Testing SQL. Enter SQL to test. This is the SQL toolbar. To execute statement here, run script, F5, commit, F2, rollback, F3, cancel, Control+Q, SQL history, F9, execute explain plan, F6, clear, Control+T. And current connections pull down here. If only one statement is in SQL worksheet, select execute statement to run it. If more than one statement is coded, position the cursor in the statement to be executed, or highlight the statement. Then select execute statement. So you can just highlight it. To expand the SQL area to a full screen, double-click the connection tab. Double-click again to shrink it back. The result the result tab shows the result of a single statement execution. So when you run your script from the worksheet, you will see the result. The execution result. SQL Developer provides many snippets of code that may be included via drag and drop or code compilation. If multiple SQL, SQL or script statements are to be executed together, select Run Script. Results show up in the script output. When a script is executed, the results show up in the script output. Highlighted here. If DBMS output, the put line was used in executed SQL or a script, it will show up in the DBMS output tab. DBMS output must be enabled prior to running your test. You may wish to increase the buffer size too. So the OWA output will show up in the OWA output tab. OWA stands for Oracle Web Agent, and so OWA output must be enabled prior to running your test. So the objects accessible to the user ID schema used to make a connection are available for browsing via the object navigator. You can see the user's spot and its objects. This navigator follows the usual pattern: expand or contract. Objects available are those belonging to the connection user ID schema. User and objects are available in some way to be to the user ID or schema. So you might have access to these objects through granting them from other users. Browsing a table, so select an object. The emp table below displays a multi-tab panel containing various bits of information about the table. So you have columns, data, indexes, constraints, grants, statistics, column statistics, triggers, dependencies, details, and SQL. Now you can double click the table imp to expand contract display. Right click on an object to display its context menu. Table menu as shown. The edit option opens a dialog to view modify the table definition. Other options open additional menus, allowing the user to issue commands graphically rather than from the command line. This is the emp table, primary key, unique constraint, foreign keys, and so on. And then you have the columns, and every column obviously will have its data type and so on, and the length. Choose table to see the list of table manipulation options. Again, so you can rename table, copy, drop, truncate, lock, comment, and so on. Choose export data to list table export options. Choose index to create or modify indexes. Choose statistics to use dbms underscore stat to gather statistics or validate structure. After choosing gather statistics, a dialog appears showing you to change the sample size and view copy the PLC code. This is the end of SQL Developer overview part 2, and I will see you in part 3. Welcome to part 3 of the SQL Developer overview. Choose a constraint to view or alter table constraint. Choose triggers to build or alter table triggers. Build a skeleton DDL that may be modified in SQL worksheet. Right-click on an object type to display its context menu. Here is the context menu for tables. Choose Create Table to display a panel for creating a standard table. Choose Add Column or Remove Column as desired. Choose Create Table to display a panel for creating a standard table. Then mark the advanced box to display other options, including external tables, index organized tables or IOT, global temporary table, panel changes for each table type. From the Materialized View context menu, choose Create Materialized View to build an M view by filling in the blanks. At the bottom of the Object Navigator, the Other Users object list, the user ID schema, names that have one or more objects available to you. Expand user ID schema to see the objects exposed to you. Store PL/SQL. As you might imagine, selecting packages, procedures, functions, or triggers allows you to display and or to alter existing stored PL/SQL. Context menus for each type of store PL/SQL allows you to create new objects using the same point by the numbers approach used for tables and materialized views. Selecting existing PL/SQL. Right-click on PL/SQL object to display the following context menu. PLSQL debugging. SQL Developer allows setting and or removal of breakpoints. Also allows you monitoring and manipulation of variables. Compile or for debug must be executed to make an object available for debugging. Once compiled for debugging, whenever executed in debug mode, the code will stop where directed. When editing PLSQL code, the icons showing here appear. Run, debug, compile, compile for debug. PLSQL name in Navigator is italicized after compile for debug. The debug run option creates an anonymous PLSQL to test the selected PLSQL. Parameter values are initially set to null, so you must provide the values you wish to test. This is the situation here, debugging display. The debugging pan shows four important subpanels. Breakpoints display breakpoints. Context menu allows new breakpoints. Smart data display breakpoints variables. Double-click value to alter. Data display all variables. Double-click value to alter. Watches display or add watches. When editing or testing PLSQL compiled for debugging, the debug menu option appears. The debugging tab provides a set of icons for controlling the debug session. Find execution point, resume, step over, step into, step to the end of method, browse, terminate, and garbage collection. While debugging, breakpoints may be set and unset by clicking in the margin to the left of the PLSQL text, or by using the context menu. Smart data and data panels show allow viewing and or alteration of values. Double click on a variable's value to display the alteration dialog. instead of double clicking on a data item, right click to display the context menu. Use the explain plan icon or menu option to show the proposed plan for a statement. How the statement is being executed. Oracle has built many of the types of reports routinely created from the catalog and $, views into SQL Developer. Some DBA oriented, some developer oriented. Before you create your own reports, look to see what's available here first. SQL Developer provides great context-oriented help, F1 key. Via the Help menu, a comprehensive discussion of SQL Developer. Via the Help menu, excellent references for SQL and PLSQL. Online documentation and support via the Oracle website and many blogs. The tool preferences menu option provides a fairly comprehensive set of tools to fine-tune SQL Developer to your needs or your taste. Free product should worry lots. Oracle's SQL Developer supports current SQL and PLSQL, provides unlimited free licenses. Licenses do not die periodically, supports many features usually available only in pay for products, PLSQL debugging, custom reporting, and more. The better pay for products are probably safe for a while. This product needs need a logo. So Oracle SQL Developer tool is an excellent addition to every Oracle DBA or developers tool belt. If Oracle keeps improving this product and keeps it free, it may put some other products out of business. And I hope you enjoy this basic introduction to SQL Developer, and I'm sure we're going to be using it during this course. So by the time we finish, you will be very, very good. This is the end of part 3 and the end of this overview. Welcome to more SQL Plus Lab 6. Our last lab, Lab 6, please do the following. Create a query that lists all employees, prompt for a job type, and only list employees in that job. Ask for a column list, column separated by commas, then list all employees showing only those columns you entered when asked. Create a simple SQL Plus report. It should have a title of employees by job, and list each job type with all employees for that job. Skip one line between jobs. Show job type, employee number, employee name, and hire date. This is the end of Lab 6 and end of the course. and I hope you learned something and enjoy the course. Welcome to installation of Oracle 12c Release 1 version 12.1 on Windows. You can download it from OTN or e-delivery. You need to sign the agreement. Once you download it, the database, and unzip the files, you'll create a directory database, and from here you can run setup to do the installation. You can ignore this, as this is just information if you require Oracle support. Create and configure database, option 1. Desktop class. You can create a window user if you wish, or you could use existing window user. Next, information about Oracle Home and the name of the database, and administrator password. We're only creating a normal database. We're not creating a container type database, which is new in Oracle 12c. It's just a basic test database. So uncheck create a container database and continue. This is the summary. Just click install. The installation starting. I will install Oracle binary, preparation, copying files. Once that's finished, it will create a database. Creating the database now, running a database configuration assistant. Once that's finished, we will go and check if we can access the database. Completed. We log in, set the SID, log in using administrator user, select some tables. Yes, so all the tables are here. I'm sure there is over 7,000 tables, so we can access the database. In Windows, you need to start and stop using service. Database is running. You can see this is so that's the database, and that is the listener. We can go and check the Oracle Home under Product 12.1 DB Home. These are the file directories within Oracle Home. Data files are stored under Ora Data, control files, log files, and database files. We'll check the network files under Network Admin. We have Listener, SQLNet, and TNS names files. So the listener configuration, you can see the Oracle Home here on the host, local host. 1521 is the port we're using. And this is TNS names. You can see localhost 1512, and the name of the database is PythonDB. You can call the database anything you like. Okay, we need to download the SQL Developer from Oracle website. As you can see, we need to accept the license agreement. We have two versions for Windows, 64-bit and 32-bit. We can download 64-bit. You need to log in if you have a user and password, or you need to create a new account to be able to download the SQL Developer. This is the file, so you need to select a location if you wish. This is the downloaded file, so we need to unzip it to a directory. It's really simple, just download it and unzip it and use it as it is. Just create a shortcut and off you go. So there is no other problems with the installation. It's very simple. With the power of editing, it's very quickly. So there you go. That's the directory. You can view the directories inside the SQL Developer, and we just click on the SQL Developer and it will load. Currently loading, version 18.1. We need to connect to the database. There you go. So we just need to add the information, connection name, database, user, and port, and so on. Since we're using local machine, we're using local host, SID name, PythonDB. Test the connection, status is success. Save the connection and connect, because you need the connection next time when you log in. You don't want to create new connection every time. So just connect. You can see we have the database already there. We can expand Scott schema. We can see how many tables we have already. These are the tables we are going to be working with.
We'll check what records there is in the department table. You can see when we describe the table, we have 3 columns. You can see the heading on top, it says the schema, the user, the database where we're actually working with. That's very important, especially if you have many databases. We can check what data we have, so it's very clever. At least it shows all the name of the tables we need to use or we want to use, and we can check how many records we have just to make sure that everything is working fine. Yes, you can see we have 4 records, and that's very good.